what's up guys? Have you guys ever wondered why you throw a ball but there's a fall straight down? It's all because of projectile motion. So in this video, we will explore together how this projectile motion works.
The title of our assignment is Analyzing Projectile Motion Using Tracker, a study on different paper airplane designs. So, what is projectile motion? Projectile motion is the motion of an object that is launched into the air and moved only under the force of gravity, and we ignore air resistance. In projectile motion, there are two components of motion. The first is horizontal motion and the second one is vertical motion. We choose paper airplanes for this study because they are simple to use and clearly show how projectile motion works. It's a fun and practical way to observe both the horizontal and vertical components of motion. In this project, we also use tracker software to help us analyze the motion more accurately and compare different airplane designs. Each design gives a different result, and that makes this experiment even more interesting.
To develop our model, we started by designing two different paper airplanes, plane A and plane B, using the same A4 size paper, but folded using two different techniques. This was to see how the shape and structure of the airplane can affect its flight performance. Each airplane was thrown at a slight angle in an open space to simulate a more natural flight path. We recorded the full motion of the flight using a video camera, ensuring that the entire trajectory was clearly visible. Once the videos were captured, we uploaded them into Tracker, a software used for motion analysis. In Tracker, we carefully marked the position of the airplane frame by frame, which allowed the program to generate valuable data. This data included horizontal and vertical positions, also known as XS and SY, and also tracked the velocities in both X and Y directions, labeled VX and VY. In addition, Tracker calculated the accelerations, AX and AY, and recorded the time for each frame. All this information helped us understand how the design of each airplane influenced its motion, making it easier for us to model and compare their flight dynamics.
Today, I will explain the analysis of results from our projectile motion experiment that was conducted using geometric window calculations and data tracker. The placement x-axis versus time graph. Both plane A and plane B show a straight line pattern that increased consistently. This proves that horizontal motion is uniform because there is no force acting horizontally after the projectile is released. Next, with placement x-axis versus time graph show a clear parabolic pattern. The projectile rises until it reaches maximum height, then falls back down. This parabolic shape is a characteristic feature of projectile motion because gravity acts continuously downward, causing the vertical motion to follow a quadratic equation. Most importantly, the comparison between manual calculations and data tracker shows very small differences. This proves that both methods are accurate and reliable for analyzing projectile motion.
In conclusion, the design of a paper airplane really affects its flight performance. For example, plane A flew further and longer than plane B. We also noticed some differences between theory and real-life results, mostly due to air resistance and the angle of throwing. Finally, the tracker software helped us analyze the motion more accurately, and it tracked the position, generated graph, and gave us important data like velocity and displacement.